All right, so let's go a little bit of an overview of what we're going to be doing today for the notes. Our topic is solving rational equations, part 1. We're doing part 1 today, and we'll do part 2 next class, which will be for you all Tuesday. All right. Our objective for today is solve a rational equation and find the possible extraneous solutions. It's 2 parts, solving, and then also checking for extraneous solutions. And you'll demonstrate this on the exit ticket, the quiz, and the unit test. Those are your 3 main ways to show me that you know this. I've broken this up into 4 levels of problems as we solve these problems. Level 1 just has one polynomial in the numerator or denominator, one in the whole thing. Level 2 has it where I have 2 of them, either right above each other or across from each other, but not diagonally. Right? A diagonal one is a level 3 problem. Okay? We'll see why that changes things when we have it be a diagonal in a little bit. But that's our main thing with level 3. And then, of course, level 4 is when we have pretty much all of them having polynomials. Right? Those are the 4 things we're going to go over. It's kind of our lead into this thing. Once we're done with that, we'll do our UDO problems. Again, 4 levels, just like the other one. Once you complete your 4 levels, you can start your exit ticket. That's about it. Let's go back up to the top. We'll start with level 1. There we go. That's a little better. So the reason I call them levels instead of different problems is because my steps are the same every time. And I'm going to follow the same steps. The only difference is that sometimes our solving for x is a little different, but everything else is pretty much the same thing. So for 1, you should always see if you can simplify. Now this is an optional step because you don't actually need to simplify. You'll always be ending up simplifying anyways. So doing this cross cancellation type stuff like the 12 and the 3 or up and down doesn't actually matter too much in the long run because you're going to get the same answer anyway. But sometimes it makes the problem easier. Like we'll see with problem 4 down below, if we cancel out, it'll be much easier of a problem. All right. So that's what we're going to talk about. The second step for all of these is to cross multiply. Now cross multiply is what we kind of call when we multiply across the equal sign, where we multiply the denominator times the numerator up here, the numerator times the denominator up here. That's what we're doing. And then finally, we're doing what we've been doing for a while now with a lot of our stuff, is just solving for x. We learned a bunch of ways to solve for x, which is factoring, using my square root method. There's a bunch of different things that we've done to learn how to solve for x. We're just going to add on here, right? And then finally, we have to check for any extraneous solutions. An extraneous solution is a solution that if I plug it in, it doesn't give me out the correct answer. So it doesn't actually work in our problem. We'll see why that is later on, but we won't see it too quickly, right? Because example 1 doesn't actually have an extraneous solution. I'll show you some examples later on that has the extraneous solution. Yeah, that's about it. All right. So let's start with this problem right here. First thing I can do, again, is the optional step, is I can either factor now or not. So let's say I factored. I would end up over here, and I would factor this to be this over here. Okay. I would notice that both the 12 and the 3 have a common factor of 3 that I can cancel out. So that'll give me 4 over 1. All right, so this would be my optional step of over here canceling out. All right. Now let's say I didn't notice that. Instead of doing number 1 first, let's say I skip that, I'm just going to cross multiply right away. When I cross multiply, I multiply the numerator, the denominator times the opposite numerator. So 12 times 1 and 3 times 3x minus 2. I do the same thing over here for the simplified form. 4 times 1, 1 times 3x minus 2. All right. This one over here gives me, when I cross multiply, this right here. 3 times 3x minus 2 equals 12. Right? Because 12 times 1 gives me 12. 3 times this just gives me those two multiplied together. Right? Same thing over here. When I cross multiply, I end up with 3x minus 2 equals 4. Right? I want to remind everybody, just in case you're a little confused right now, why we have two separate things that's going on. This right here is if we did not simplify. This one right over here is if we did simplify. Right? So if I did notice, I can cancel out that 12 and 3 a little bit. End up doing this. As you can see, if I cancel out here, it looks a little bit nicer out down here, our first step when we cross multiply. All right. Now, same thing over here. I need to solve this equation. So I'm going to divide both sides by 3. Divide this side by 3. Divide this side by 3. These 3's cancel, which is kind of what I want. And then 12 divided by 3 is 4. So maybe you notice that I ended up with the same thing, both cases. So whether or not I cancel now or later doesn't actually matter. So I end up with the same thing in the end. Then it's just factoring a little bit. Add 2, divide by 3. I get 3x equals 6 and x equals 2. Right? Same thing over here. Add 2, divide by 3. It's the same problem, so of course we get the same answer. So now we know that one of our solution is x equals 2. Following these steps. Are there any questions on step 1, 2, or 3 before we move on to step 4? Checking to see if it is an extraneous solution. Anybody have any questions on step 1, 2, or 3? Some good questions are, if you're completely lost, hey, I'm completely lost. Can you redo everything? Like, hey, I didn't understand one of these steps. Could you tell me again about one of those steps? Can you reiterate one of your things? Any of that type of stuff. Yeah, I can do that. So someone asked me to re-go over it, so I'm going to do that. I'm going to re-go over this side right here, following the same steps without actually simplifying first. Right? So let's clear off my screen. First step I need to do is to see if I simplify. Now I'm going to say I didn't notice that the 12 and 3 can be simplified. So instead, I'm going to skip to step 2 and I'm going to cross multiply. When I cross multiply, I multiply denominator by opposite numerator. So 12 times 1, 3 times this. 3 times 3x minus 2 gives me this side, and 12 times 1 gives me this side. Now there's a reason that we do this that's kind of hidden when we cross multiply. Right? I'm going to rewrite this real quick just so everybody can see. The reason that I multiplied by the other one is really I'm doing it on both sides. Right? I got this 3x minus 2 over 12, and this equals 1/3. If I wanted to get rid of this dividing by 12, I'd multiply by 12. And I'd do the same thing on the other side. So I notice that these two cancel. Then I'm multiplying by 12 on this side, just like we did when we cross multiplied. To do the same thing, get rid of this 3 on this side, I multiply both sides by 3, multiply this side by 3, and now these 3's cancel. All right, and so I'm left with 3 times 3x minus 2 equals 1 times 12. So that's kind of why my cross multiplying works. Now, if you don't want to memorize that part, you can just remember the cross right here, do that whole thing. But again, that's the reason that cross multiplication works. Let's clear that off so that we have some more space. Again, we're cross multiplying, cross, cross. I have this equation. Then it's just solving this equation. Divide both sides by 3, divide both sides by 3. 3x minus 2 equals 4. Add 2 to both sides. 3x equals 6. Divide by 3, x equals 2. That's my final answer. Now the last step I need to do, which is the new step, is to check my extraneous solution. Now what we always have to worry about when we have rational expressions is that we could be dividing by 0. In this case, we can't be dividing by 0 because there's no polynomial in the denominator. Right? So since there's no polynomial in the denominator, there won't be an extraneous solution in this case. Right? Does that make sense to everybody? Do you have any questions on that? So again, extraneous solutions are solutions that might have a problem when I plug it in. Right? Since I can plug in 2 right here and nothing bad's going to happen, this will work. On the other hand, let's say I had a different problem. Like, this is just an extra example. I had a problem that the answer was x equals, let's say 3. All right. And my equation was 1 over x minus 3 equals something, let's say a over b. These two numbers don't really matter, right? And I got this as one of my answers and I plug it back in. If I plug it back in, I get 1 over 3 minus 3, which gives me 1 over 0, which is not allowed, because I cannot divide by 0. So x equals 3 would be an extraneous solution, so it's no longer a true solution to my problem. Right? So that's what an extraneous solution means. It's a solution that I get out by doing some type of math, like I did up here. But then when I plug it back in, I end up with something that goes wrong, like dividing by 0. Right? Another thing where we saw extraneous solutions earlier in this year is when we were talking about absolute values. We were solving absolute value functions, and they were equal to a negative number. Right? That made it impossible because absolute value is always positive. So we couldn't have a negative number. So that's where you might have heard of extraneous solutions before. Right? In this case, it's any solution that when I plug it in, I end up dividing by that number, dividing by 0, right? Which is not an okay thing. All right. Are there any questions on that? On what an extraneous solution is, how we got it, any of those type of things? Anybody need me to repeat it? Anything? So again, this was just an extra example that I was just showing to show an example of an extraneous solution. It's just one that I made up in my head. It's not an actual problem that we've gone over or anything. It's just, you know, showing that this is what would happen if we had an extraneous solution. Any other questions? All right then, let's move on. I'm gonna clear off our screen. We're gonna move on to level 2. If you're still a little confused about extraneous solutions, that's fine. We'll have an example of one on level 4, but it might make it more concrete. But for now, let's move on to level 2. Again, like I said before, level 2 is the exact same steps. See if you can simplify, cross multiply, solve for x, check for extraneous solutions. All right, same thing every time. We do the same thing here. First step is I need to see if I can cancel. I go across and up and down. Since nothing matches this way or this way, there's nothing I can really cancel. So this one right here is done. Right? Can't cancel anything. Next step is to cross multiply. Now I want to remind everybody, because I see this problem most when we're doing these problems at the beginning, everybody forgets it's an invisible over 1 right here. Because any number is really over 1. Right? So if you're ever trying to find a fraction, it's really just an invisible over 1. Right? Then I do the cross multiply again. 1 times x plus 2, 1 minus 2x times 5. Put it up here. I'll put it down here tonight. Oops, that's not what I wanted. There we go. So I cross multiply, get these two over here, 1 times x plus 2 over here. Right? Once I'm done cross multiplying, I should have something without any fractions, which is nice because we know how to solve this. We've done it multiple times. Distribute the 5, combine like terms, all that good stuff. When I distribute the 5, I get x plus 2 equals 5 minus 10x. Then I get all my x's on one side, all my numbers on the other. Add 10x, subtract 2, I get 11x equals 3. Last step, divide both sides by 11, I get x equals 3 over 11. That'll be my answer. Before we check for our extraneous solution, are there any questions on how we did step B or step C? Yeah, we can go back to C. So again, when we're doing C, we're solving this right here, which just means we need to simplify this. The first step I did is I noticed that to solve these when I just have x's, not x squared terms, I need to get all my x's on one side and all my regular numbers on the other. To do that, I need to distribute this 5, both of these. All right, 5 times 1 gives me 5. 5 times negative 2 gives me negative 10. Now, just like I said before, we need to get all of our x's on one side, because I can't have them on both sides. Once I move this one over, I get 11x, and I have to move the 2 over to the opposite side so I can solve. 3. Divide both sides by 11, and get x equals 3 over 11. Are there any more questions on B or C before we move on to D? All right. Doesn't seem to be any questions. I'll give it about another 5 seconds while I take a sip. All right. So my next step is to check for extraneous solutions. Like I said before, I could plug this number in and see if it works. Now, what you might notice is that 3 over 11 is not a nice number to plug in. It's going to be kind of hard to simplify that and everything. So what is sometimes easier, like in this case, is to check if the denominator that I plug in would be 0. Because really all I'm checking for in these problems right now for an extraneous solution is if my denominator right here will give me 0. Because I can't divide by 0. That's where I can make a mistake. So what we call that is our restriction. So I'm going to check my restriction. So I'm going to set 1 plus 2x equal to 0. And 1 minus 2x equal to 0, not 0. And I'm going to solve. All right. Subtract 1, divide by negative 2. And I end up with, so do that whole thing. X is not equal 1/2. Now this is the step that I have to check. I need to see if this, x equals negative 1/2, and this match. If they match, then it's an extraneous solution. If they don't match, since this does not match, x equals 3/11, is a solution. So again, since they don't match right here, this is a solution. It's not an extraneous solution. Excuse me. And again, I do this right here, the restriction part, to see if this is an extraneous solution. Because the only way we can have an extraneous solution in this problem is if I plug in my number and I end up with 0 on the bottom. Since I plug in here and it doesn't end up being 0, we're fine. That's about it. Are there any questions on this problem now that we've gone through all 4 steps? Any questions before we move on to level 3? Again, if you're completely lost, that's a good thing to ask me. Hey, I'm completely lost. Can you re-go over the whole thing? Hey, I'm not really understanding this. Can you start from the beginning? That type of stuff. Right then, we'll move on to level 3. If you come up with a question, we'll come back to it. Level 3. Level 3 is a little bit harder. Right? It steps up a little bit because of the fact that when I cross multiply, I end up multiplying 2 polynomials. All right, which means we're going to end up with an x squared term, which means we're going to have to solve a little bit differently. On the other hand, up here, as you can see, we only ended up with x terms, which makes it really easy to solve. Same thing with this one up at the top. We only ended up with x's, which makes it really easy for us to solve. What we're going to find here, again, x squared terms. So first thing I need to do, again, check to see if I can simplify. I can't cross this way or up and down because nothing matches. So what I'm going to do is have to cross multiply. Numerator times denominator, denominator times numerator. I'm going across. Put it up here, did I put it down here? 2 times 2 gives me 4. X plus 3 times x minus 3 gives me this. All right. That was my cross multiply step. I checked off, I tried to simplify, then I cross multiplied. Before we move on to solving for x, are there any questions on how we cross multiplied or simplified, or tried to simplify, I should say? Any questions before we move on to solving this equation? All right, then. Now we're going to solve this. What I should notice is that these 2 things right here are, what do we call those? Difference of 2 squares. All right, that's the difference of 2 squares property. So I can get the x squared minus 9. Now, some people were confused about this in my last class when we were trying to solve this. And they tried to do this level 3 thing that we're doing right now for every single problem that they've ever seen with a level 3 problem. This only works this x squared minus 9 part only works because of the fact that this is a difference of two squares. Because when I multiply these out, they cancel out, right? Because the x minus 3 in this one gives me a negative 3x plus 3x, which cancels out, all right? So that's why it becomes x squared minus 9. It won't happen every time when we do this, only when we have perfect difference of two squares. I want to remind everybody that because a lot of people were getting that problem wrong down below on the you-do problems. Right? So I just wanted to remind everybody of that. Next thing, since I have x squared minus 9 equals 4, I'm going to move my 9 over, and I get x squared equals 13. And then to get rid of this squared term, I'm going to square root both sides. Square root, square root. Now what I want to mention and remind everybody is that whenever we square root a square, we have to add this plus or minus right here. That's a key part. This is two different solutions right here. It's a positive square root of 13 and a negative square root of 13. Now the last step I have to make is to simplify. Turns out the square root of 13 is prime. 13 is prime, so I can't simplify it any further. So I just end up with x equals plus or minus the square root of 13. All right. That is my two solutions right here. Are there any questions on how we solved our equation? How we solve for x? All right. And we'll add our restrictions now. Now, what you might notice is that this isn't a very nice number to plug in. So this would be a great example of one where you don't want to plug in and crank out and see if they match. All right, it'd be very hard to do that. Because to do that, you would need to use the conjugate of each one, multiplying by all that stuff, and it would just be a mess. So what's even easier is to check our restrictions. So we're going to set our denominator, this x plus 3, equal to not 0. Then we're going to solve. There it is. Again, I'm checking my restrictions just like we do in all the things that we've done so far in our previous classes. All right. We set our denominator, wherever there's an x, equal to not 0, and then we solve. Subtract 3, and we end up with x minus 3 is not equal to 0. All right. Now, again, what I need to check is to see if this matches this. Since these don't match, x equals plus or minus square root of 13 is my solutions. Notice that there's two different solutions right here. It's not just one. Plus and minus means two, both positive and negative. Are there any questions on level 3 before we move on to our hardest level, level 4? All right then, let's move on to level 4. Again, like usual, if you come up with a question, you can come back to it. Level 4 is a little bit harder, as you can see, because we have 4 different things. which makes things a little bit more challenging. But I still do the same thing. See if you can simplify, cross multiply, solve for x, add your restrictions. In this case, you can actually simplify, not this one. Maybe you notice that the x plus 2's can be canceled out. Right? So what I could have done is canceled those x plus 2's and ended up right away with x minus 1 equals x squared plus 2x minus 3. Right? Because those are both on the denominator, and I can cancel out crosswise. Right? So then we have a nice number, nice thing right here that's really easy to solve. Now, let's say we didn't notice that. We decided to cross multiply instead. We would cross multiply. Again, multiplying x plus 2 times x minus 1 and x plus 2 times this one. Now you got to get used to canceling when you can, all right, and figuring out when you can cancel. Since these are both multiplication between these two, I can cancel out these x plus 2's, right? So I can cancel out this one, x plus 2 with this x plus 2. The reason I can do that is because they're both matching on both sides. Now later on, we're going to have a restriction because of that. Because when I cancel out something like this, we can have that problem. But we're already going to have that restriction up above. All right. So when I cancel those out, I end up with the same thing I had below if I had noticed I could cancel. I get this right here. I click right. All right, and then it's just solving. Move everything over to the one side like we did for our warm-up this morning. And I get x squared plus x minus 2. All right, move this over, move this over. Now that I have all of them together, I can factor. Now I use this method of factoring whenever I have an x squared term and an x term. So if I have both of those, I'm going to put them all on one side and I'm going to factor. I get x plus 2 times x minus 1. Break it apart. X plus 2 equals 0. X minus 1 equals 0. And solve. Right. X equals negative 2. X equals 1. Right? That's my process of finding my solutions. All of this. Now what's going to happen, x minus 2x equals 1, is I'm going to have to check my restrictions. Now this is one where I could plug it in and see maybe that way that it doesn't work. If I plug in negative 2 here, then we're going to have a problem. I can see that negative 2 gives me 0 on the bottom. That's not going to work. But what I can also do is check my restriction. So I set my denominator equal to not 0, and then I solve. X equals negative 2. Cannot be that. Since, let's highlight all this. Now, this matches one of the solutions. Since this matches one of the solutions, x equals 1 is our only solution. We had to get rid of this solution right here. Okay. This one right here does not actually work as the solution. X equals negative 2 is an extraneous solution. Extraneous solution. Which means it's a solution that we got out that again doesn't work. If I plug it in, I don't get the correct answer out. So since it matches our restriction, doesn't actually work, can't work. All right, so x equals 1 is my only correct answer. Are there any questions on example 4? Hopefully you notice if I cancel first, it ends up being the same thing here. So all these steps are the same down below. Right? But again, I'm going to repeat my question. Are there any questions on level 4? Before you move into the you do problems, and you're working on your own. All right. I'll be here if you have any questions. I'm going to clear off my screen. You have some problems down here to work on, all 4 of these problems. I would complete them before you start the exit ticket because it's a good little warm up. Make sure you know what you're doing. Put your answers in the chat and I'll tell you if you're correct or not. Let me know if you have any questions on any problem or where you get stuck on and I can help you. All that good stuff. All right.